Welcome back to the Gen Chem Fundamentals series presented by MCAT Genie. Today we're going to talk about concentrations. So the most typical way that concentrations are presented on the MCAT is going to be molarity. So molarity is going to consist of the moles of solute divided by the total volume of the solution in liters. And so I drew this triangle here to show you that if you want to convert between molarity, moles, and liters of solution, then it's really easy to do so as long as you have two of the three of these. So ultimately speaking, just to give a visual representation of this, when we're dealing with a solution, there are different concentrations of solution. If I take a glass of water and I put a little bit of salt in it, a tablespoon, it's not the same concentration as if I put 3 tablespoons. So in this case, we're just representing how much of the solute, which dissolves in the solvent, but the more of these things or particles or ions or atoms or molecules that we have as solute within the solvent, then the more concentrated the solution is, and therefore the numerator here would be larger. So this is just what molarity represents. So every time you see molarity, I think it's really good practice to adjust to, okay, every time I see molarity, then that just means moles over liters. It's really useful to rewrite it as such. And then if you need to convert to volume, the liters will have to go to the numerator. And if I need to keep moles, then I can just multiply by a volume and the liters will go away. And so this is a really good way of remembering whether it's multiplication or division in any given scenario. You don't have to memorize it. You just have to know what the units will end up being. All right, so I'll give a quick, easy example of this. So if I was to take 1 mole of sodium, and then I was to put that in 1 liter of solution, then really easy, this is going to be 1 molar sodium. And so this is very simple to understand, hopefully, based off of what we've said already. So why don't we move into something a little bit more complicated just to really get the brain working, get the gears going. So what if I was to ask, and this could be possible on the test at any point, and I said, hey, we have a stock solution of 2 molar hydrochloric acid, 2 molar. So this would represent 2 moles per liter of solution. And then I said, hey, I need you to take a 20 milliliter vial or 20 milliliter amount of that stock solution. And I want to know what the mass of HCl is in that 20 milliliters. So now all of a sudden I've introduced mass, and that might not be what we talked about. I thought we were talking about moles and liters, but we can turn the moles of solute into mass very easily as long as we know the molar mass. So what I'll just make a note of for now is that we're dealing with moles over liters, which is our concentration here. Keep that in mind. And then we are given a volume, which is milliliters. So I'll need to multiply by some amount. We'll change milliliters to liters. Then the liters will cancel out. And then that's going to give us moles. So then once I have that, then I can multiply by grams per mole. As you can see, the moles will cancel out. And then we'll end up with grams. But we're going to do this one step at a time because that's how I like to do it. That's how we keep things in order. So let's start with converting this to 2 moles per liter, and this is how I'll write it down. If I know that I'm only using 20 milliliters of this, then it would be smart for me to multiply by 20 milliliters. However, I can't just multiply by 20 because that would be a mistake because the denominator here is liters. So I have to change my milliliters to liters. If you watched my unit prefix video, you'll know exactly how to do this. We just tack on a good little 10 to the negative 3 to represent the milli, and then we'll call that liters. So then if we multiply, what are we going to get in terms of moles? Well, I'm going to end up with 2 times 20, which is 40, times 10 to the negative 3 moles. And so that is a really easy way to figure out how many moles were in the 20 milliliter amount of the 2 molar HCl solution. So if I have 20 milliliters of that, I'll have 40 times 10 to the negative 3 moles. of HCl. So if you were to convert that into proper scientific notation, then that would essentially be 4 times 10 to the negative 2 because I'm already moving the decimal place over to the left one. So I don't need to move over 3 times. I can move over 2 times. Okay. Anyways, that's just a little scientific notation reminder. So now I know I have this many moles of HCl, then I'm going to multiply by, what was it again? I need to find grams, right? So if I'm going to find grams, I need to know how many grams are per mole of HCl, also known as the molar mass. So if I do a quick search here, then I know that the molar mass of HCl is approximately 36. Is a decimal, but let's call it 36 just to make things simpler. Let's assume that we're dealing with 36 grams per mole. And keep in mind on the MCAT, you will not have a calculator. So it's good to get used to these types of calculations without one. And so the way I would go about this is I would say, okay, well, I could approximate this to 30. I could also approximate it to 40 if I want to. Or I could just multiply it by 36 by itself. If you find yourself doing math and you're writing it out, then you probably didn't need to do that too much. Like I could take 36 times 4, and then I can sit here and I can say, oh, 4, 2, okay, whatever. But maybe a simpler way of going about it, just as a tip, would be, okay, 30 times 4 is 120. 6 times 4 is 24. So if I take 120 and I add 24, I get 144. And so that is another way that you can do your math if that's helpful to you by any chance. And so that was the coefficient. And then you can take that times 10 to the negative 2 because we still have that here in the scientific notation. And so ultimately we have that many grams of HCl. If you're to turn this into proper decimal form, because we don't really need the scientific notation at this point, we'll just go 1, 2 to here, and this will go away, and then we'll just call this 1.44 grams of HCl. That means that if I have a 2 molar HCl solution and I take 20 milliliters of that, and then I say, okay, how many grams are there? I know both that there's 4 times 10 to the negative 2 moles, and I also know that that is equal to 1.44 grams HCl approximately because I approximated this molar mass. So I hope that this example is good at showing how you're going to need to manipulate through the molarity, which is moles per liter. It's good to write it out. Then we need to change the milliliters to liters, but it's really not that hard because just multiply by 10 to the negative 3 and then that follows you. So then the coefficients, you just multiply them, and the scientific notation just follows along. And so then we know it's 4 times 10 to the negative 2, and then I take the molar mass and I can multiply by that. And keep in mind, if you write out the units, you'll know if you need to multiply or divide because the units that you have left over on top need to match up with the answer that you're expecting. So thank you all for watching the video. Really appreciate it, and hopefully see you again soon.